In this video, I'm going to help you through some vocabulary on perpendicular and parallel lines. For example 2 here, it says for lines to be parallel, what must be true about their slopes? Well, if lines are going in the same direction, then that means they need to have the exact same slope, meaning the exact same fraction and exact same sign, positive or negative. For me to give 2 examples of slopes that are parallel, I just need to make sure that my slopes are identical. So if I have a given slope of 7, my parallel slope would also be 7. If I had a given slope of -4/3, my parallel slope would be -4/3 as well. They have to be identical. Now for number 3 here, it says for lines to be perpendicular, what must be true about their slopes? Well, their slopes, in order to be perpendicular, must be opposite signs, and they must be reciprocal. Opposite signs and reciprocal fraction, meaning flipped upside down. For me to give 2 examples of slope that would be perpendicular, I'm actually going to use my given examples up here. Let's pretend I was given a slope that was equal to 7, positive 7. My perpendicular slope would be opposite sign, so negative, and if this was a fraction flipped upside down, it would be 1/7. Now, likewise, if I was given the slope of -4/3, my perpendicular slope to that would be opposite sign, which would be a positive, and flip your fraction upside down, 3/4. For question 5, it says, what form must an equation be in for you to know the slope? Well, in order to know the slope, you need to have slope-intercept form of a line, or you need to have point-slope form of a line. Now, number 6 asks you, what is always true about the slopes of horizontal and vertical lines? Well, horizontal lines, we've used this phrase, HOI, have zero slope. Zero slope. Horizontal lines have zero slope, and that's what this O stands for in the middle of HOI. And vertical lines have undefined slope because our phrase is VUX, and that helps me remember the U in the middle here stands for undefined slope. So first, just kind of knowing those 2 things. What is always true about horizontal and vertical lines? What is always true is that they are always perpendicular to each other. Question number 7 says, write the equation of a line that would be perpendicular to y = 2. And here's a hint, it may help you if you graph that line. So I'm going to graph the horizontal line of y = 2. So my horizontal line is going to go left and right, and it's going to cross the y-axis at +2. Now pick a vertical line. Draw a vertical line on your paper, and you will have a line perpendicular to your horizontal line. There's a lot of perpendicular lines you could draw, but the one that I drew was x is equal to +2. You could have picked over here 5. You could have picked x is equal to -3. It's up to you, your choice. Now, I have a second example here that goes through 4 questions that deal with parallel and perpendicular lines. And now that we've just kind of refreshed on our slopes, parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes, I think we're ready for some examples. So I have 4 examples here for us to work through. My practice says for number 1, write the equation of the line in slope-intercept form. So let's just quickly review that. That is the format y = mx + b. So this is the format I want my answer to be in. Now, I may have to use a different form to start with, for example, point-slope form, but this is what I want my final answer to be. So I want to write the equation of a line in slope-intercept form that is parallel to the function -3x + 4. So my slope in that given line is -3. And if I want parallel, I need to have a slope that is exactly the same, so negative 3. I also need it to go through my line, the point 4, 1. Now, if I know a point and I know slope, there's an equation for that. Point and slope is the equation, point-slope form, that I'm going to use for my point and my slope. And that form looks like this. Y minus the y value of my point equals my slope, and then in parentheses, x minus the x value of my point. So point-slope form because I was given a point and slope. Now I'm going to solve for my slope-intercept form by distributing my slope and solving for y. So if I distribute my slope, I'm going to have y minus 1 is equal to negative 3x plus 12. And if I solve for y by adding 1 to the other side, I will have my slope-intercept form, which is negative 3x plus 13. And this is the line that will be parallel to my given line, and it will have this point through that line. Now in the second example, I want to have a line perpendicular. Now in my slope that's given here, my coefficient of my x is negative 1. And if I want perpendicular slope, I need it to have the opposite sign, which will be positive. Now 1 is kind of like the fraction 1 over 1, and if I flip that upside down, I still get 1 over 1. So my opposite reciprocal slope will be positive 1. Now I also need to use a point, and the point that they're telling me for my line to go through is the point 3, negative 6. So if I'm given a point and I'm given slope, I have to use point-slope form, and that's what we're going to do. Y minus negative 6 is going to mean this is going to be a plus, equal to my slope of 1, and then x minus my x-coordinate of 3. Now if I distribute my slope and I solve for y, I will have my slope-intercept form. So y plus 6 equals 1x minus 3. If I subtract my 6 over, I will have my slope-intercept form of this line, which will be x minus 9. All right, here is number 3. So for number 3, it says, I want a perpendicular line to y equals 8. Now I'm going to give you a hint like we did up above, and that's going to be to graph. So my graph is going to help me visualize this. If I have y equal to 8, any function y equal to a number is going to be a horizontal line with 0 slope. Now if I want a perpendicular line, I can pick any vertical line. Any line you want. I'm just going to pick a random vertical line, and I'm going to call this vertical line x equal to, and I'm going to pretend that that's equal to 3. And a vertical line and a horizontal line are always perpendicular to each other. Here's my last example for you. I want a line parallel to the function negative 1/4 x plus 5. Now my slope given here is negative 1/4, and if I want parallel slope, I need to have my m be exactly the same, negative 1/4. I also want to use the point that I'm told, negative 8, 6, and if I'm given a point and I'm given slope, I have to use point-slope formula. So y minus the y value of my point, 6, will equal my slope, negative 1/4, and then in parentheses x minus negative 8, which will turn that into a plus. Minus a negative will be plus. Now if I distribute my slope, I will have y minus 6 is equal to negative 1/4 x minus a fourth of 8 is 2. And if I add my 6 over to this side, I will get my slope-intercept form, which will be y equal to negative 1/4 x and plus 4. And this will be my slope-intercept form.